Hello, my name is William.
My name is Dad.
My name is Jess, and our project is the vessel traffic system. So the vessel traffic system involves two parts: the transmission of data of ships and the receiving of the data of ships. The transmission is shown on the right, and the receiving is shown on the left. On the right, the user can input any types of data such as latitude, longitude, speed of ground, length and width, to transmit over onto ThinkSpeak, which is a cloud-based service, which the left, which will then be read by the program on the left. If you run that program, you'll then be shown a visualization of the ships moving from one point to another. As you can see, the ships are moving. And now let's go over the features of this program, such as the filtering, the speed alarm, the proximity alarm, and the actual speed of the ships.
So how the filtering of the ships work is that when you click a certain checkbox and then you filter out the ship, and then the ship will be filtered. You can also re-show the ship back on the map by checking on it and then clicking filter ship again. So in order to implement this, we use different conditional flags that determines when a certain checkbox is checked. So when one checkbox is checked, is the total number of check nodes will equal to 2, and this basically means that a certain checkbox is not checked. So we determine which one is not checked by using a string comparison. So ship 3 is equal to 0. That means that ship 3 is not included in checkbox, and then we will filter out ship 3, and we keep ship 1 and 2 on the map. The same goes for the other programs. We just use different if statements to determine how many check nodes there are. And we also included a different filtering button for when the tracking button is disabled. This means that the ships are not moving, and we can still filter it out by graphing the ship at their current location, using the same method of checking which ship node is not included in the array. And now William is going to talk about how we move the ships.
When the tracking enabled button is pressed, if the ships have not moved yet, then we do a calculation for the inputted value from ThinkSpeak, so that we can calculate velocity in the x direction and velocity in the y direction from being only given the speed on ground. We can also calculate a vector for the movement of the ships, given the initial latitude and longitude and final latitude and longitude. Next, we have a loop, a while loop, so that after or every 0.25 seconds, the previous ships are deleted, and then depending on how many of the check nodes are pressed, we would reprint the correct ships. Another feature that we have is a proximity alarm, right over here. This proximity alarm will activate and change color into a black color when the ships are within 5 units of each other, and will reset to a cyan color when the ships are far away. We also have a maximum speed on ground alarm, or max speed alarm, that we get from a max speed on ground edit field, and we compare it with the speed on ground that we get from ThinkSpeak. Just a quick recap of our program. We have 2 parts to our program. We have a program that sends data to ThinkSpeak, and we have a program that receives data from ThinkSpeak that graphs ships moving when enabled. It can filter ships. It has a speed alarm, proximity alarm, a table to show the speed value, and a maximum speed on ground edit field. This This is our vessel traffic system project. Thanks for watching.